If you have a number and you want to subtract, let's say 3. 10 minus 3 is 7. Another way of thinking about it is to do 10 plus negative 3. This is also a positive 7. Now what did I do here and what did I change? Well, in the first case, we don't write it usually, but you could see this. 10 minus positive 3 is 7. This equation right here is the exact same as this equation. 10 minus positive 3 is 7. 10 minus positive 3 is 7. Sometimes if you see the minus and the plus, it's easy to get confused about what you're doing. But what you're really doing is taking away a positive 3 from 10, and that's 7. What did I do in this equation down here? What did I change? Well, instead of subtracting a positive 3, I switched the signs and I added a negative 3. So there's a switch going on right here. I took the positive sign and I switched it with the negative sign. So I'm adding a negative. Now this is a nice feature because there's a relationship between these two numbers. 3 and negative 3 are called opposites. This means they are the exact same distance from 0 on a number line. So if you have a number line and 0 is here, well, the absolute value to 3 is 1, 2, 3, so it's 3. And the absolute value to negative 3 is negative 1, negative 2, negative, so it's 3 away from 0 as well. So they're opposites and there's balance. Remember, if we add 3 and negative 3, two exact opposites, we get 0. So we can use that idea in subtraction and addition. Whenever you're encountering a problem where you're subtracting something, you can choose to add its opposite. And that often helps me. I actually enjoy doing addition more than subtraction. That's an important idea. And we can apply it the other way too. If we had a 10 minus a positive 3, and this also means that we can apply it the other way. If we had 10 plus negative 3, and this was throwing us off, we could then subtract the additive inverse of negative 3. So we can do 10 minus a positive 3. So if you prefer to do this equation right here, because you recognize that it's just 10 minus 3, then go for it. Because this first equation, although I'm comfortable with it, you might decide my mind likes to work better with subtraction in this case. So switch the number, change the second number here to its additive inverse or its opposite. That can become very useful to you. Distance is a really important concept that's always positive. We have this person standing exactly where the other person is. The distance between them is 0. But wherever I move this person around the other one, there is some positive distance between them, something you can measure. It doesn't matter if it's on this side or this side right here. Distance is always positive. Always. However, difference, it could be positive or negative, as you've probably seen, depending on the order of the numbers. It could be positive or negative. For example, 3 minus 1 versus 1 minus 3. Now, 3 minus 1 is 2, and 1 minus 3 is negative 2. So in this first case, we have a positive 2, in the second case we have a negative 2. And it really depends which order you're choosing. If the first number has a lower value than the second, you're going to get a negative value, and vice versa. If you have a 3 here and a 1 there, and the 3 has a higher value, well, then you're going to get a positive value. The connection here between the difference and the distance, you might see it already, but let's look at it on the number line. Set up a couple of numbers here. Here's 3, 2, 1, negative 1, negative 2. In the first case, what is difference? Well, difference is, it's like movement. Think of numbers on the number line. When you're adding, you're moving. When you're subtracting, you're moving around, and you're moving in a certain order here. You're going up to 3 from 0, and then you're taking away 1. You're finding the difference, so you're moving 1 to the left. So on the number line, you start here in 0, hop up to 3, and then down 1 to 2. So the difference is almost like this process where you're moving from 3 down 1 to 2. And that's what difference is. And that's why it changes here in this case. Instead of starting at 3, we're going to 1 first, so we're hopping up to 1, and then we're taking 3 away from that 1, so down 1, 2, 3, and we get negative 2. So the difference is this movement and that happens in the order that they give it to us. What's the relationship? Well, if we look at 2 and negative 2, they both have the same absolute value. Positive 2 up here is 2 units away from 0. That's absolute value. Negative 2 is over here, but it's still only 2 units from 0. And what if we looked at the distance between 1 and 3? What would we find? Well, let's just quickly sketch that on our number line. We'll fix that over here. Here's 1, 2, and 3. Well, the distance is from this point measured over to this point right here. And that distance is 2, which equals these values right here. So we could say that the difference gives you the distance if you take the absolute value of the difference. Taking that a little bit slower, what I'm saying is it doesn't matter what two numbers you have. Let's say you have negative 3 and 5. It doesn't matter which way you subtract them. You're going to get in both cases, well, here negative 3 minus 5 is negative 8, and 5 minus negative 3 is positive 8. In both cases, you get the absolute value of 8, which is the distance between those two numbers. So to find the distance, you could draw this number line and count how many hops you're going between points, or what you can do is just subtract one number from the other and then take the absolute value. That is the interesting connection here.